You know that feeling when you're hitting an absolute ceiling with traditional web development? Like, no matter how many nested loops or complex database queries you write, the application still feels, well, kind of rigid and, let's be honest, a bit dumb? Well, welcome to the paradigm shift. In today's explainer, we are going to totally demystify the transition from that old school traditional dev mindset to building massive, highly scalable, next generation AI agent systems. If you're used to the old days of full stack development, you're for sure in for an incredible ride. Today, we're unpacking exactly what it takes to architect intelligent, autonomous applications from the ground up using literally the most bleeding edge paradigms available to developers right now. Let's get into it. Here is our agenda for today. First, the 4 rules for AI apps. Next, unpacking cloud native. Then, workflows versus AI agents, followed by the actor model. And finally, we'll wrap up with the OpenAI Agents SDK basics. All right, section 1, 4 rules for AI apps. So, to build for the future, developers absolutely must embrace 4 non-negotiable pillars. Historically, traditional dev often meant monolithic architectures, right? Stuff you built locally and deployed on specific, rigid servers. Well, that simply doesn't work in the era of AI. You have to be AI first, cloud first, have the total flexibility to develop anywhere, whether you're on a Mac or a Windows machine, it shouldn't matter, and ultimately deploy anywhere, meaning your app is entirely cloud agnostic. Building scalable systems from day one requires a total commitment to these 4 rules. Because honestly, if you compromise on even one of these, your system is going to hit a massive bottleneck the second your user base starts to grow. Now, adopting an AI-first mindset means recognizing the profound difference between actually engineering intelligence and just bolting AI onto some old legacy app. For a long time, companies thought they were doing AI just by slapping a basic chatbot widget into the bottom right corner of their existing website. Yeah, that is not AI first. True AI-first architecture means you're utilizing the best agentic frameworks, like OpenAI's SDK, as your core routing and logic engine right from the start. You're not looking at a standard software problem and asking, hey, how can I add an LLM to this codebase? Instead, you're looking at the fundamental problem and asking, how can an AI agent solve this autonomously? It fundamentally changes the very first line of code you write. Moving right along to section 2, unpacking cloud native. There is a massive, massive distinction between simply hosting an app on a cloud server versus engineering it to be truly cloud native. When you just host an app, you're usually chained to the specific infrastructure of that one provider. But when you build cloud native using tools like containerization and Kubernetes, you're abstracting the application away from the underlying hardware. This is a game changer because it empowers you to avoid vendor lock-in entirely. If you construct your agentic application correctly, you can seamlessly migrate your whole operation from Google Cloud over to AWS or over to Azure without rewriting your core code base. It gives you incredible resilience and is the true realization of that deploy anywhere mandate we just talked about. Imagine you're relying on an AI agent for a critical task. You type in your prompt, and the loading wheel just spins and spins. It's incredibly frustrating, right? If we're scaling globally, we immediately run into 2 massive hurdles: speed and security. Users today are absolutely not going to wait around for a sluggish response. And furthermore, for these agents to be truly useful, users are handing over incredibly sensitive, proprietary data that simply must be safeguarded at all costs. So, how do we solve this? Well, to fix the latency issue, we obviously can't rely on a single server room in California to process a request from a user sitting in Tokyo. The delay would render it unusable. Instead, cloud providers use distributed edge computing. They spin up data centers globally so the processing happens geographically closer to the end user. As for privacy, the stakes are just as high. We solve this by relying on audited SOC compliance and strict role-based access control, or RBAC. This ensures a user's proprietary prompt data remains completely siloed, meaning even the engineers building the system can't just peek into a user's private agent interactions. By combining edge computing with strict compliance, we ensure the app is both lightning fast and totally impenetrable. Okay, section 3, workflows versus AI agents. Here is the core logic shift you need to grasp. As you increase the autonomous decision-making power of your app, you inherently decrease its strict predictability. On one side of the spectrum, we have traditional workflows. These are built entirely on deterministic, hard-coded if X, then Y statements. They're highly predictable, sure, but they have zero agency.
On the exact opposite side, we have AI agents. Instead of writing out every single step, you just give the agent a high-level goal, and the underlying LLM figures out the best path to get there. It's incredibly powerful. But you are trading away that rigid line-by-line predictability in exchange for dynamic intelligence.
This quote right here really captures the fundamental shift of deploying agents. Think about it like navigating a busy city. A traditional workflow is like giving someone hyper-specific turn-by-turn directions. Drive exactly 50 feet, turn left, wait 10 seconds, then turn right. If a single road is closed, the whole thing fails completely. An agent, however, is like just handing someone the destination address. You don't know the exact route they're going to take, but you trust their brain to navigate around traffic and detours to actually get there. Let's look at a real-world example in customer service. A rigid workflow halts immediately when it hits a conversational wall. Imagine an automated system asking a user, "Please enter your zip code." And the user replies, "Actually, what is your refund policy?" A traditional workflow bot will completely ignore the question and blindly repeat, "Please enter your zip code," which is just endlessly frustrating for the user. But an autonomous agent? Armed with agency and an understanding of the actual end goal, it will seamlessly pivot, warmly explain the refund policy, and then naturally guide the conversation right back to gathering those required location details. I love this analogy. Think of ordering lasagna at a restaurant. A workflow is like a completely robotic chef. If the recipe calls for ricotta cheese and the kitchen is out of ricotta cheese, the robotic chef literally throws a fatal error code, shuts down the entire kitchen, and refuses to serve you anything at all. But an agentic chef, having true agency, understands the larger goal is simply to feed you a delicious meal. It will just improvise, substituting mozzarella or offering a baked ziti alternative on the fly, saving the meal without skipping a beat. Now, as we scale these autonomous chefs up to an enterprise level, we hit a massive infrastructure wall. An agent needs to remember the context of a conversation, what tools it's already tried, and what the user actually wants. If we have 1 million active agents running globally, a sudden server restart causing widespread amnesia would be a catastrophic failure for the business. So, how do we keep their memories perfectly intact? Which brings us to Section 4, the actor model explained. The actor model is what solves the statefulness problem for millions of AI agents running simultaneously. In this paradigm, every single agent acts as an independent actor. These actors run on their own, maintain their own distinct state or memory, and communicate with each other asynchronously through message passing. Think of asynchronous messaging kind of like sending a text message rather than waiting on hold on a live phone line. The system doesn't get all jammed up waiting for a response, which allows for massive, unhindered concurrency. Let's walk through a critical failure scenario. Say you just write a normal Python class for your agent. Well, it's bound to a single machine. If that server cluster goes down, poof, the Python class is gone, and that user's entire session is wiped out forever. Not great. But the actor model uses this brilliant process called dehydration and hydration. When an actor is idle, or if a server fails, its exact memory state is safely dehydrated and saved to a database. When the user returns, the actor simply wakes up on an entirely different server, pulls its memories back from the database, hydrating itself, and seamlessly finishes the user's sentence as if literally nothing happened. Finally, Section 5, OpenAI Agents SDK Basics. Okay, moving away from deep infrastructure, the OpenAI Agents SDK simplifies complex software architectures down to just these 3 fundamental components: agents, handoffs, and guardrails. Stripping away all those highly convoluted loops and endless abstractions makes a developer's life significantly easier. You simply define the agent, manage the handoffs between multiple specialized agents, and enforce guardrails to keep them safely on track. Let's look at handoffs. Once a task is handed off, the expert agent takes full ownership. Think of a bustling hospital. A triage agent greets the incoming patient, figures out exactly what they need, and routes them to a specialized expert, like, say, a coding agent or a complex math agent. In older dev frameworks, that expert would have to report its findings back to a manager bottleneck before finally responding. But OpenAI's model empowers that specialized expert to deliver the final output directly back to the user, completely eliminating unnecessary communication steps and massively cutting down on latency. And then we have guardrails. Because agents are granted so much freedom and inherently have that low predictability we talked about, guardrails act as the required safety net for all this creative freedom. If a user asks for biryani, you want to make absolutely sure the agent doesn't creatively drift off topic and serve up pulao instead. A guardrail is a separate, localized check that validates the output in real time, catching any hallucinations and guaranteeing that the autonomous actions align strictly with the intended goal, long before the final answer ever reaches the user. The shift from rigid if-else logic to autonomous, agentic systems isn't just a minor update, it is a once-in-a-generation leap in software development. The days of exhaustively hand-holding software through every single possible edge case are rapidly fading away. We are now officially in the era of designing highly intelligent systems, deploying them seamlessly across any cloud environment, and letting the agents autonomously take the wheel. So the only question left is, what incredible solutions will you build with this newfound agency? Thanks so much for joining me on this explainer, and I will catch you on the next one.